Hello everyone, welcome back to another video by HVs. Yes, sorry for the sound. Okay, sorry for the mic problem. I'll be mixing late fixing here. So let's not waste any time and we will see what we learned like the previous video ending. We learned the final product of the photosynthesis, that oxygen and carbohydrates are the final products of photosynthesis. So I would like to ask you one question. If you have understood the chapter, imagine life on Earth without photosynthesis. It is unimaginable. Of course, first thing comes in your mind. Second thing in your mind is there will be no food for organisms which eat plants. If there's no food for the organisms which eat plants, the organisms which eat plants will die. And if they die, the organisms which eat them will die. And if they die, the organisms which eat that organism will die. And so on, things start dying. Eventually, humans will also die. And secondly, the oxygen, the main source of oxygen is also photosynthesis. Oxygen is only produced during the process of photosynthesis. So life will be impossible. Life will be impossible in the absence of photosynthesis. So we'll continue. So we have seen that. So now I'm going to draw a structure of leaf, as I told you in the last video. So first, the leaf has this, then the leaf, the section of the leaf, like the leaf internal, which can be seen through microscope section. Oh, I scrolled down by mistake. This, then 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 this. I hope you all have the textbook. I'm just trying for explaining it. Oh, this is stylus guys, so excuse me. I hope you're not getting bored. Yes, here we are. I've drawn a rough diagram. Here we are with our rough, beautiful diagram. Beautiful, just beautiful, man. Imagine. Beginner drawing that. Imagine, just imagine, okay? So this is the process. These cells are chlorophyll. Then comes guard cells. These are the guard cells. I'm gonna explain everything. The guard cells are the cells which are a stomatal opening. They are in a stomatal opening. When the plant is breathing, the guard cells open. But these are like flaps. When it is breathing out, they become like this for breathing. Okay? Yeah. Yes. Okay? These are guard cells. Then comes the stomata. This is the stomata. Even this is the stomata, okay? This is the stomata. Any opening is a stomata, and two cells, what do we say, side by side to it, are the guard cells. Understand that? Okay, so now let's see. So we have learned a lot about plants right now, but we need to learn about more plants, like desert plants. The best one. Oh, desert plants. Desert plants. Desert plants do not have leaves like cactus, or maybe their leaves are very thin like a palm tree. I'm in a palm tree. A palm tree's leaves are like this, and the roots are very, very, very deep. Okay, leave about that. And a cactus, the leaves are reduced to spines, and the spongy green stem does the process of photosynthesis. The leaves are reduced to spine. to prevent the loss of water. How is the loss of water conducted? Through the process of transpiration. So transpiration, if I say transpiration, in that, through the stomata only, they lose water in the form of water vapor. When the water comes here, when the water comes, like this is the leaf, the water comes here and through the sunlight it gets transpiration only takes place, I think, during day. Mind that. Okay, you can do that experiment by, if this is a leaf, 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 if this is a leaf. I think it's not written in a textbook, but if this is a leaf, tie a polythene around. Tie a polythene around it. It should not touch the leaf, okay? After 2 to 3 hours or 4 hours, go and you will find small droplet. That is due to transpiration. Tie it tightly, okay? Airtight. That is transpiration. Remove it, don't keep it there. The leaf will die. So, the leaf will die, yeah. So, the next thing is the various type of plants. You see, sometimes you see that the some plants have leaves red or some other color, but the large amount of red and brown and other pigments like that, they mask green color, which is full. I can't represent it, just I try my best. This is green, and this is red, so it will hide a bit of green color. I left the patch there. This patch they will mask the green color, okay? So, but they will mask some green color, but there is one plant. Now it's time to move forward to the parasitic and host relationship. So this example in plants, I'm giving you plants, is a plant called Cascuta. A plant called Cascuta. A plant called Cascuta. Okay? So a plant called Cascuta, or I guess the Hindi name is, yes, the Hindi name is Amarpel. More commonly in India is known as Amarpel. Amarpel. So Cascuta Amarpel, it has leaves of red color or yellow color, and does not even have a little bit of green pigment. That means it does not have chlorophyll. That means it cannot carry out photosynthesis. So this is a large tree. This is a large tree. Scuta will start growing on top of it and take the nutrients. It will not give anything in return. It will just take the nutrients. So parasite is an organism. Parasite is an organism that feeds only feeds, I guess I should say, that only feeds and derives nutrients but does not give anything in return. That means the parasite is a trouble to the host. The parasite is a trouble to the host. The parasite does not do anything good for the host and takes only nutrients. Other examples of parasite are lice, bleach, ticks, mosquitoes. Mosquitoes come and suck your blood, but they do not give you anything in return. The only thing a few mosquitoes give you is malaria or dengue. All harmful diseases. They don't do anything good to you. Lice sticks to your hair, body or hair, and only takes blood. Does not give you anything. Only pain. And what about ticks? Ticks are found in pets. Those are young archimids with 8 legged. That means 8 legged. They feed on the blood of animals. Lice cannot be on animals because it's adapted to human hair only. But ticks can only be on animals. It does not be on humans that frequently. Leech is also like lice. It is a worm type structure that gets bigger and bigger from back while it sucks your blood. They don't do any good to us, but they only give us pain. So these are parasites. Now the second thing we are going to learn are insectivorous plants. A new topic. Insecti insectivorous plants. Insectivorous, as the name suggests, these plants are partially heterotrophs. Partially heterotrophs. So these plants, what do they do? The best example I can give you is a pitcher plant. A plant called a pitcher plant. Pitcher plant. So the pitcher plant is a plant with a pitcher type structure where the pitcher type structure is a modified leaf. Okay, so inside the plant has very attractive color, so that it's a very bright color, so insects get attracted to it. When insect is sitting here, this part is very slippery. As soon as the insect lands here, it slips down here. Okay, then in the pitcher plant there are hair directed downwards. Okay, there are hair directed downwards. So when the insect falls, it gets entangled. Entangled here. The lid closes. The lid closes. And then the digestive juices are secreted, and the insect is dead, digested, and absorbed. The plant gets its nutrition. Now, the other example I can give you, which is not mentioned in the textbook, is a Venus flytrap. So, a Venus flytrap is an open-mouthed like structure with a with like if it is its upper flap, it has spines like this, and down flap is spine. Inside it has no spines. So when the insect lands here, it closes. The spines prevent the insect from coming down. Here are the spines. Here only, not inside. Digestive juices are again secreted, and the insect is digested. Okay, there is the same process everywhere. Okay, so now let's learn about the lichens. Now the lichens, they have two. They have fungi. Lichens have fungi, and algae. Fungi provides the algae with food and shelter, and water and shelter. Example: this is a bread. This is a greeny part. So the algae prepares food with the process of photosynthesis, and the fungi on top of it protect, gives shelter and water. Okay, so the algae, in return of the shelter and water, it gives back it food and nutrients. Okay, and then it's the same. I'll give you an example. I have a home, my friend has a restaurant. Okay, so my friend will live in my home. In return, my friend will give me free meal in his restaurant every day. So I am providing him shelter, and he is providing me nutrients. Okay, so we are giving each other a return, something in return. It's not like he's coming to my home, he's eating everything, he's using my electricity, so he's a parasite, I'm a host. But this is a symbiotic relationship. The same is followed by fungi and alga. Okay, so only one topic is left. We will cover that later. We'll cover that today or later. Thank you for watching, and guys, sorry for the delay, and I guess this will be over by the next video. Okay, Sorry guys, okay, bye. See you. Please like and subscribe and comment down below. Bye. Bye bye.